In this next section, we're going to be covering matrix inverses and coding and decoding. So at the end of the video, we're going to learn how to use matrices to code and decode messages. But before we do that, we do have to know how to find the inverse of a matrix. So let's go ahead and start with that. Matrix inverses is when you have a matrix and you find another matrix that what we call an inverse, and they're going to be inverses of each other. So first thing you have to know is the notation. If you have a matrix called matrix A, when you find the inverse, you have to denote it like this, A inverse. So A with little -1, that's the way you're going to read it. A inverse is the inverse of course, matrix A. Now, when we ask you to find the inverse of a matrix, you do have to keep in mind that only square matrices will have inverses. A square matrix is a matrix that has the same number of rows as columns. So a 3x3 matrix can have an inverse, a 2x2 matrix can have an inverse, but if you have a rectangular matrix like a 2x1 or a 3x4, those cannot have inverses. They have to be square, meaning that they have to have the same number of rows as the same number of columns. Now, once you find a square matrix, you can find the inverse of it, but just note that not all matrices will have inverses. There's going to be some matrices that you just can't find the inverse for. So that's pretty much the introduction. Now we're going to go over how to find the inverse of a 2x2 matrix. So for example, if I want to find the inverse of this little matrix right here, this one's a 2x2, what I'm going to do is I'm going to use the following formula. Okay, so anytime you want to find the inverse of a 2x2, you're going to use this formula. Now, if you want to find an inverse of a bigger matrix, like a 3x3 or 4x4, then that's a different method. But in this video, we're just going to be focusing on how to find the inverse of a 2x2. So if you have a 2x2 here, let's go ahead and call the elements A, B, C, and D. To find the inverse, you are going to have to calculate this little fraction right here. So it's always going to be 1 divided by whatever two numbers are in this column, in this diagonal multiply. So you're going to do A times D, always minus this diagonal, B times C. Okay, these you're going to get a number. After you calculate this, you have to get a number because again, your matrices is composed of numbers. So again, multiply A times D, subtract B times C. That's going to be in the denominator, and then you're going to have a fraction here. You're going to have 1 divided by something. Now, after that, you are going to have to manipulate the matrix. What you're going to do is, if you notice, A and D are going to switch places, or you're going to have to flip A and D. If you notice, A and D are now they flipped places. So the D is now here in the upper left, and the A is here now in the lower right. And then B and C, if you notice, they stay in the same place, but now they're going to be opposite signs. So if the B was positive, now it's going to be negative. If the C would have been negative, now it becomes positive, right? Same thing goes. So that's pretty much how you're going to calculate the inverse. Of course, once you find this, and you are going to have to distribute this into every single one of the elements inside your modified matrix. Okay, so I know this might make no sense, so don't worry, we're going to do an example right now. But you do have to know this little formula here. So this formula, you're going to use it anytime you want to find the inverse of a 2x2. So let's go ahead and just dig in straight to a problem here. If you notice, I do have my formula right here handy because I know I'm going to use it. The problem says find the inverse of the matrix below. I notice that this is a 2x2, so I take out my notes and I see that that's the formula I'm supposed to use. So all you have to do is just use the formula. So here I already have it all set up. If you notice, I have 1 divided by A times D, which is -2 times 4, minus 3 times -3, right there. Okay, so if you notice, this negative is from the formula. Like the formula always says we have to have a subtraction there. And then I just replace my values. Now, in the matrix next to it, if you notice, I do have to make the modifications that the formula says. So I'm going to go ahead and erase this now. And if you notice, we know that these two have to change place. So my 4 is now up here, my -2 is down here. And these two change signs. So this becomes a positive and this becomes a negative. So if you notice, that's how I got these there. Okay, so that is the setup of how to find the inverse. All we have to do now is just simplify. So of course I have to do this first part here. So -2 times 4 gives me -8. And yes, believe it or not, that's a -8. Minus -3 times 3 gives me a -9. So I am going to end up with a -8 minus a -9. When you have two negatives next to each other, they become one big plus. So I have -8 plus 9, which is just 1. So I have 1 divided by 1. And then this matrix, I just bring it down. So that matrix stays the way it is. Now, Lucky for us, 1 divided by 1 is just 1. So when I distribute that into the matrix, all the numbers stay the same. So that's why they just stay exactly the same. But just so you know, when you have a fraction here, you are going to have to distribute the fraction inside as multiplication. But again, lucky for us, it was just a 1. And then once we do that, that's it. That is my inverse. And again, it's not official until you denote it properly. So since the name of this matrix was A, this is going to be A inverse, and that's my answer. So I think it was pretty simple. So again, that formula is going to be your best friend when trying to find the inverse of a 2 by 2 matrix. Let's go ahead and try another one here. So here we have the inverse of a matrix, and this matrix is called matrix M. Now, to find the inverse again, just use the formula. So here is the setup. 1 divided by, again, it's always this diagonal, so negative 1 times 4, always minus, and then this diagonal, negative 2 times 3, right there. And now the matrix has to be modified. These two numbers change place, so now the negative 1 is here and the 4 is there. And these two numbers change sign. So now this is going to be a positive and this one's going to be a negative, but they stay in the same place. So I still have my 2 and my negative 3. From here, all we have to do is simplify. So negative 1 times 4 gives me negative 4 minus negative 2 times 3 is negative 6. Obviously, when you have two negatives here, it's going to become a plus. So negative 4 plus 6 gives me a 2. So that's how I end up. And again, don't freak out. This whole thing ends up being just 1/2, right? Because you have to simplify it. And this fraction here, this matrix here is just copy pasted down here. Now, unlike the last problem we just did, when we ended up with a pretty 1, I distributed, nothing changed. But now since I have a fraction, which is 1/2, when I distribute it inside, it's going to multiply everything. So this is what you're going to do. I'm going to do 1/2 times 4. So the way you multiply fractions is 4 times 1 is 4 and then over 2. That's how I got the first one. Negative 2 times 1/2 is negative 2 over 2. Okay, I'm sorry about that. This one should be negative and this one should be positive. I'm sorry about that. I didn't copy paste it properly. So if you notice, this comes here. So this is a positive 2 and a negative 3. Okay, and then when I do the 1/2 times the negative 3, gives me negative 3 over 2. And then the 1/2 times negative 1 gives me a negative 1 over 2. And again, this was a positive 2, my bad. So when I multiply times 1/2 is 2 over 2. Now, anytime you have a fraction, you have to ask yourself, can I simplify? Which, of course, in this one we can. 4 divided by 2 is simply 2. 2 divided by 2 is simply 1. Negative 3 over 2 cannot be simplified, so it stays as is. And negative 1 over 2 cannot be simplified, so it also stays like that. Once you have simplified everything, then you're done. And again, you have to make it official by providing the proper notation. So since the name of this matrix was M, my final answer is going to be M inverse equals the answer that I got here. So again, you just use the formula, you will get your answer. Okay, again, just to make sure we're okay, we're going to do one last one before we move on to the next part. So find the inverse of the matrix below. Again, anytime you see it's a 2 by 2, you just pull out your formula. So here's the setup. Again, it's A times D, so negative 6 times 25, and then 5 times negative 30, which is right here. And now the matrix, again, you have to modify it. These two numbers change place. The negative 6 is still negative, the 25 is still positive, but they just flip. And then the negative 30 becomes a positive 30. So again, I'm sorry about that there, positive 30. And the 5 becomes a negative 5. Okay, so we have a positive 30 and a negative 5 there. And then we just calculate. So again, simplify. Negative 6 times 25 is negative 150. And then minus negative 30 times 5 is negative 150. Now, when you have negative, negative, it becomes positive. So I end up with negative 150 plus 150, which is 0, right? So this whole thing here becomes 1 over 0. And then this one just copies down, right? So it just comes down after I modified it. Now, in your calculator, if you go ahead and calculate what is 1 divided by 0, you're going to see that your calculator just starts going crazy, right? You cannot divide by 0. So when this happens, this is how you know that this matrix does not have an inverse. So whenever you're calculating it, you're all happy, all excited, working out the problem, and then you run into this issue where you end up with a 0 in the denominator, just drop your pencil and stop, and you just say that this matrix, if you want to sound fancy, you can say that it's invertible, meaning that it does not have an inverse, or you could just put it does not have an inverse. And there you go. So hopefully you were able to catch that. This only happens again when your denominator ends up being 0. And then there's no need to do anything. No, there's going to be no inverse that exists. All right, so that's how you find the inverse of a 2 by 2. And again, finding the inverse is very important because it helps us with the next section of this video. So in this section, we're going to be learning how to code and decode messages using matrices. Back in the day, believe it or not, when they wanted to encrypt a message, they would use a matrix. And I'm pretty sure it's still being used. If you're into computer science, you might know a little bit about this. But we're going to learn how to do this by hand, on how to code a message and how to decode. But we're going to go ahead and start it by coding. So in case you didn't know, coding means when you encrypt a message. So if I want to encrypt a word, it means that from letters, I convert it into numbers. And nobody can find out what the message says unless I provide them with additional information. So this is what we're going to do. When you have a message that you want to code, first thing you're going to do is you have to rewrite your word into numbers. So you're going to rewrite the word numerically. We're going to start using this little thing right here where A is going to be represented with the number 1, B with the number 2, and so on and so forth, all the way to Z being represented with the number 26. So first thing you're going to do, you're going to come up with your word and you're going to convert it into numbers. Now that's too easy to decode, right? So we're going to go ahead and do an additional step. So once you convert it into numbers, you're going to have to list these numbers by columns. So you're going to create a square matrix and you're going to start by listing the numbers down. So you have to fill up a column first, and then you start on the top left and then you fill down. And once you reach the end, then you start on the next column. So again, you're going to start here, 1, 2, and then you're going to start up here, 3, 4. Okay, so that's the proper order you're going to do. So again, start at the top, fill up the column, and then move on to the next column. Okay, once you create your matrix, this is the formula you're going to be using. Okay, so again, this is very important. I would write it down on my notes and be like, this is the formula I'm going to use when I want to code a message. So you start with a message and you want to encrypt it. So what you're going to do is that you're going to grab a coding matrix, which in all of these problems is going to be provided to you. So again, coding matrix is going to be provided. You're going to multiply it times the message that you just created right here, right, in your matrix. So that's the message. And then once you multiply whatever matrix you get, that is your message that has been encrypted. So that's going to be your message that has been coded. Again, if this makes no sense, don't worry, we're going to be doing a few examples together. So here we go. Like I told you in the last slide, the coding matrix is provided to you. If you do encrypt a message and you want the recipient to be able to decode it, this is the matrix you would have to provide for them or to them. So here's the thing. Here's the coding matrix that they give us. And using this coding matrix, they want us to encode the word snap, right? So just a simple word, and we have to learn how to code it or how to encrypt it. So here's the thing. We are going to use our formula. That's all you're going to do. So coding matrix, done. It's right here. So we have this one done. Now we have to come up with a message. The message is the word snap, but obviously it has to be in numerical form. So what we're going to do is we're going to look at the letters of the word snap and we're just going to translate them to numbers. And again, it's always nice to have this handy. So N is the word, S is the letter 19. So that's the first letter. N is, where is it? 14. So that's the next one. A is the number 1. And then finally, P is the number 16 right here. Okay, so look at that. You have converted the word snap into numbers. And again, that's super simple to look at or to see. So we still have to do an additional step just so to make sure that our message is safe and nicely encrypted. So now that we have this, we have to convert this into a matrix. Now, in order to do that, remember, you do have to list them in order. So look at this. The 19 goes up here. The next number has to go down here. Okay. The next number goes up here. And then the last number goes down here. So again, this is the order. You start here, you go down, and then you continue here and go down. This right here, again, I'm sorry about this. This is your message. Okay, so I'm just going to put the word M-E-S, you got it. This is your message matrix because the word, you have put it into a message. So we have our coding matrix. Now we have our message. Now the only thing I have to do is multiply them together. So my answer is going to be the coding matrix times the message matrix. And whatever I get, that's going to be my encrypted message or my encrypted matrix. Of course, you do have to know how to multiply matrices. So if you don't know, just make sure you go back to your previous note packet. And if you were to do this in an assignment, you do have to show all your work. So we're going to go ahead now and multiply these out. If you remember from the last video, you do have to do always row times column. So I'm just going to do this quickly. If I lose you, just make sure you let me know and we could do additional examples together. But this is what you do, right? So in order to find the first number here, you have to multiply the first row, remember it's always rows, and the first column. So -2 times 19 right here, and then -3 there, okay? And then again, to find the next number here, now you do the first row, but now times the second column, right? So -2 times 1 right there, and then -3 times 16 right there. Okay, so I'm not going to do the whole thing because, again, this is something you should already know. If you do have trouble with this, make sure you go rewatch the video about multiplying matrices. Okay, but once you do this, of course, we simplify, and this is the final answer I get. This is your encrypted message. So you are already done. The last thing you have to do is just convert it back to a string because your final answer cannot be a matrix. It has to be a string. So what we do is, again, you start always from the top and down. So my first answer is going to be -80. Comma 113, and then you go down here. So -50 first, and then the 67. So believe it or not, the word snap has been encrypted successfully into these this little string of numbers. Again, back in the day, people would do that just to make sure their messages were safe. I know it's kind of a long process, but it ensured some sort of security. If you want the recipient to decode it, though, you would have to provide this, and you would have to provide the coding matrix. And then towards the end of the video, you'll see the process, the backwards process of how to start with the coded message and then how to get back the original message. Okay, so I wasn't sure if that was enough practice, so let's go ahead and just do one more of these. So here we have a coding matrix, and they're asking us to encode the word life. So first thing you do, again, look at the word and translate it into numbers. So here we go. So the word life converts into the numbers 12, 9, 6, and 5, because those are the numbers that pertain to the letters L, I, F, and E. And again, all I did was just use this little chart. Okay, now that you have this, you make it into a matrix. Again, we start in the upper left, we go down, so 12, 9, and then the 6 and the 5. Order is very important. If you mess up the order, you're going to get the incorrect answer. So remember, always start at the top, fill up the column, and then start at the next column and fill it up. Okay, so we have that there. And then we just use the formula, right? I'm going to multiply the coding matrix, which is right here. And again, I'm sorry about that. And then you multiply times your message, which is this one. Again, your message is the one that comes from the word. So all I'm going to do now is I'm going to multiply the coding that was provided and the message that I created from the word that I was given. And just like we did in the last slide, then I just multiply them. Same thing, row times column. Okay, so again, in case you forgot, we do a row times a column for this one. And then this row and this column for this one right here. And then we do the second row and the first column for this one. And then we do the second row and the second column for this one right here. Again, if you need help with that, go rewatch the previous video. Once I did those in my calculator, I got this right here. And that's it, we're done. That is how you find the coded message. So the word live converts to the numbers 93, 12, remember that's the order, and then 51, 8. Okay, so that is always going to be the order. So remember, always start from the top, go down, and then top, go down. If you do this incorrectly, you will get the wrong answer. All right, I hope that made sense. That's how you encode or encrypt a message. Now, I know you've all been waiting for it. How in the world do we do this backwards? If I am the recipient, how do I convert those numbers back into letters? So I'm glad you asked. That's the next thing we're doing, right? So how to decode a message. So what happens if I'm the person receiving this really weird string of numbers? How do I convert them back to a message? So this is what you're going to do. So in case you didn't know, right, decoding, it means that you're going to use matrices to decrypt. So decrypt means to find the word or the message. So what you're going to do is step number 1, and this is the reason why we started this video with inverses, Because the first thing you have to do is you have to find the inverse of the coding matrix. The coding matrix is going to be provided to you. You're going to have to go about it and find the inverse first. Once you find the inverse, then you just use the formula. This is a variation of the previous formula. So if you want to find a message, you're going to multiply the inverse of the coding matrix, because remember that's what that means. The inverse, you're going to have to find it first, and then you can multiply it times your encoded matrix. Believe it or not, that's going to give you a message or a matrix. Of course, it's going to give it to you in numbers. So the next thing you have to do, of course, is just convert that numbers back to a message. But we'll do an example. Just make sure, again, you have this formula and you label it as decoding. This is when you want to decode. This is when I give you the numbers and you want to find the message. So we're going to do maybe, I think, like 2 examples together. So here we go. Use the coding matrix there, and there is this really weird letter or word, represented by these numbers. We have to figure out what it is. So in order to do that, step number 1 says that I have to find the inverse of this matrix. So yes, there's no way about it. You have to find the inverse. With your permission, I did cheat because we already found the inverse of this one in a previous example. So if you do not have the inverse, you do have to go out of your way and find the inverse first. But again, I'm sorry, but we did this one together already. So if you're not sure what I'm talking about, look at a previous example. There's an example where we start with this and you found the inverse. Okay, so this is the inverse. So now what I'm going to do is I'm just going to use my formula. It tells me to use the inverse of the coding matrix. So you don't use the original one. You use the inverse, which is right here. And then you multiply it times the encoded matrix. Okay, so this is what happens. We found the inverse of the coding. So again, we don't use this one. We use the inverse. So again, look at this. I found the inverse, which is right here. And then we multiply by the encoded matrix. Now, here's the thing. They didn't give us an encoded matrix. We have to create it ourselves, but we know how to do it. Again, the first number goes in the upper left. The second number fills up the column. So we go down 13. And then the next number starts in the top, and then the last number goes in the bottom, 89. Okay, so again, just make sure you're following the formula. Now here comes the fun part again. We just have to multiply these and we will get our message, our numerical message. So here we go. We're going to multiply these out. Again, it looks like a lot. I'm so sorry, but again, it's from a previous video. So again, row times column. That's how I got the first one. And then row times column. That's how I got the second one. And then row times column right there. I know you're like, why is she doing this? Just to remind you. And then row times the second column. That's how I got that. Okay, once I go through that long process, I end up with this right here. And look at that. Believe it or not, that is our message. We're so close to just decrypting it. Just so you know, make a little note of it. If on your message you end up with negative numbers or numbers that are greater than 26, then obviously there's something wrong. Because again, in order to translate this into words, they have to represent letters from the alphabet. So again, you cannot have negatives, you cannot have numbers greater than 26. So all of these numbers look pretty. So now I just use my numerical alphabet, and that's how I'm going to be able to decrypt the message. So again, the order is always the same. So I have to start with this number here, which is the number 3. So our first letter in our message is the word C. And then you have to go down. Remember, now this is the next one. So 1 is the word A. Oh my goodness, what can it be? Okay, C-A. And then the next one is 19. So 19 is the word S. So pass. And then the number 8 is the letter H. Okay, there we go. It makes sense. Cash. There you go. So that's it. So I was able to decrypt the message because I was provided with the coding matrix and I was provided with a little string of numbers. So that's the way you go about it. Of course, if you end up with like a really weird message that makes no sense, then that means maybe we did something wrong, right? If I end up with the word flu, or well, not flu, but you know what I mean, like a word that makes no sense. So since this is an actual word, then I think we did a pretty good job. So that's how you go about those. Again, just to make sure it makes sense, let's go ahead and do one last one together. So we have a coding matrix being provided to us, and they're asking us to decode this. So that is going to translate to a 4-letter word at the end of the day. So let's go ahead and get started. The formula says I first have to find the inverse of the coding matrix. So here's my coding matrix. I have to find the inverse of that. Again, we did this We did this previously, you guys, so I don't want to go through that again, but you would have to find the inverse first. Again, you know how to do it because we did several examples together at the beginning of the video. So once I have my coding matrix, I find the inverse, which I'm going to replace right now here. And then this string of numbers, you have to make it into a matrix. But again, it's always in the same order. So negative 51 and then the 69 on the bottom, and then negative 78 and the 110 on the bottom. Now, the inverse of this one becomes this, because again, we did it together in a previous example. This one just comes down. Okay, something else that I forgot to tell you guys, you cannot multiply these backwards. The coding matrix, the inverse always goes first. If for some reason you put these backwards, you are going to get the wrong answer. So when you multiply matrices, you cannot flip them around. It always has to be in that order. So make sure you follow the formula exactly the way it is. So the coding matrix goes first, or the inverse of it, and then your message that has been encoded. Okay, so that's how I got those. And then from there, we just simply multiply. Again, I'm not going to make you go through that struggle of me circling things, but you got it, right? So it's row times columns, and I have to show all my work here. And then all of these simplify to this. Again, before you move on, always ask yourself, do I have any negatives or do I have any numbers greater than 26? Obviously, I don't, so it's a good sign. Now, let's see if we can actually come up with a decent, appropriate word that makes sense. So this is my answer, and again, the order is always going to be the same. So you start with this number here. So 3 is the letter C. 15 is the word O. Okay, so we have C-O. 18 is the letter R. Core. And then 14 is the, okay, it makes sense, it makes sense. So we have the word corn, right? Again, if your word does not make sense, I would go back and make sure I did everything properly. But there you go, that's how you decode a message. So again, you guys already know how to find the inverse of a matrix, which will help you decode and code messages. Now remember, your best friends in this section are going to be the two formulas. Make sure you have them written down and then you have them properly labeled.